And welcome to another video. In this video, we are going to solve one problem from Leetcode, that is Koko eating bananas. So in this problem, they have given a number array that represents the number of bananas in each pile, and they have given some time limit, that is in hours. And a monkey is allowed to eat from one pile at each hour, and we need to find the minimum rate at which monkey can eat so that it can finish all the bananas in these piles, in all the piles within these hours. So this is the problem statement, and I'm going to explain this problem along with taking this as an example. So we have to find what is the minimum eating rate of the banana of the monkey so that it can eat all the bananas from the within this time interval, within these many hours that is given h. And one more condition is monkey can eat from only one pile at each hour. So if the rate is more than the number of bananas which are present at a particular position, then it will eat all the bananas which are present in the pile, and then it will waste that hour, and in the next hour only it will try to go for another pile. This is the approach, and I'm going to explain with one more example how this works. Let us go through some examples to understand this question. In this problem, they have given, consider this first problem. The piles of bananas are 3, 6, 7, and 11, and monkey should be able to eat all these bananas within 8 hours. That is h equals 8. So at each hour, monkey will be able to eat from only one pile. So we need to keep this in mind while calculating how many hours a monkey will take to each pile of bananas. So this is one thing. And what is the minimum rate? So given hours will be always be greater than or equal to number of piles, because at each hour monkey will be able to eat only one pile. So minimum rate should be 1, because if it is 0, monkey will not be able to eat anything, and maximum rate will be the maximum bananas at a particular pile. If you go through all the piles and what is the maximum value present at a particular pile will represent the maximum rate, because even if monkey is able to eat more than that maximum value, it does not matter, because if monkey is able to eat at 15 bananas per hour and maximum is 11, so monkey will only able to eat 11 only. So let us go through some examples to understand how this works. So first problem is 3, 6, 7, and 11, and given h is 8. That means monkey should eat all the bananas within 8 hours. So we know that our minimum rate can be 1 and maximum can be 11, because 11 is the maximum value which is present in that particular list of piles. So then we will start whether with the rate of 1 bananas per hour, monkey will be able to eat. So for the first pile it will take 3 hours, for the next pile it will take 6 hours, and for next it will take 7, and next it will take 11. So if we sum all these hours, it will become 27, which is greater than 8. So k equals to 1. If rate is 1, then monkey will not be able to eat all the bananas within 8 hours. What happens if rate is 2? If k is 2, at that time it will take 2 hours for eating 3 bananas, because for at the first hour it will eat 2, and the next hour it will eat just the 1. So for 6 it will take 3 hours, because at the first hour it will eat 2, second hour it will eat 2, and third hour it will eat 2. So totally it will take 3 hours. And for 7 bananas it will take 4 hours. Calculation is similar to previous calculation. So it will take 4 hours. For 11 bananas it will take 6 hours, because at first 5 hours it will eat 2 bananas each, and at the last hour it will eat 1 banana. So total it will take 6 hours. So if we sum all these numbers, then total will become 15. That is still greater than 8. This means even with the rate of 2 bananas per hour, monkey will not be able to eat all the bananas. So what happens if k is 3? If k is 3, monkey will take 1 hour to eat 3 bananas, 2 hours to eat 6, and 3 hours to eat 7, and 4 hours to eat 11. So total will become 10, which is still greater than 8. So monkey will not be able to eat all the bananas within 8 hours. So 3 is also not the answer. What happens if k is 4? If k is 4, monkey will eat within 1 hour 3 bananas, and it will take 2 hours to eat 6, and it will take 2 hours to eat 7, and it will take 3 hours to eat 11. So total will become 8, and we got to know that monkey will be able to eat all the bananas within 8 hours, and given limit is also 8 hours. So 8 becomes equals to 8, and this means if monkey eats 4 bananas per hour, and monkey will be able to eat all the bananas within 8 hours. So our answer will become 4. Minimum k will become 8, not 8, 4. So this is how we arrive at answer in a brute force method. So instead of going this way 1, 2, 3, and 4, we can use binary search within that range to arrive at this solution. We will do binary search within that range. I'm going to explain that approach as well. We are still talking about the first problem. We got to know that range will be from 1 to 11. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So our left will point to the 0th index and right will point to the 10th index. So I will write the index as well, and we will do binary search over this rate range. So once we compute the mid will become the index 5, that is the element 6. Then we will check whether monkey is able to eat all the bananas with this rate, that is mid. So we will write a function for that. We will look into that implementation of the function in the next section. But just for the pseudocode, we are writing this. If monkey is able to eat all the bananas with the mid rate, then we know that mid is a possible answer. We have to search for better answer in the left range. Mid is a possible answer because monkey is able to eat all the bananas with mid bananas per hour. So we have to search from left to mid minus 1 for better answer. If if this is the case, if monkey is able to eat all the bananas with mid rate, if that is not the case, then we have to start searching for answer in the mid plus 1 to right range. This is the approach that we are trying to follow, and we will do the same thing. So we are going to write the code for this as well. Let's write the solution as we have discussed before. So minimum eating speed, and first we have to decide the range. For deciding the range, we have to get to know what is the maximum file. So initially I will initialize it to 0, and then we will go through the file. For filing files, if file is greater than max file, then we know that we have to update the max file. So we will get to know the max file, and now we got to know the range at which we have to find the rate. So our left will be 1 and our right will be this max pile. While we have a valid range, that is left is less than or equal to right, then we will compute the mid. Mid will be equal to left plus right divided by 2. So once we get the mid, then we have to check if can it with rate. So we are going to pass mid as an argument, and we will, if that is the case, then we have to, then we know that mid is a possible answer. Then we will declare a variable name minimum k. So we are going to update minimum k to mid, and we will start searching for a better answer in from left to mid minus 1. If that is not the case, then we know that we have to start searching in mid plus 1 to right range. So this is the approach that we are going to follow. Only thing is we have to implement this function can meet with rate mid. So we are going to implement here itself can it with rate. So we are receiving k as an argument. We also need files and h. We are going to pass these things as well. Initially, we will declare an hours, total hours to keep count of how many hours monkey is using to eat all the bananas with a rate k. So for pile in piles, here we will decide with the rate of k, how long does monkey take to eat those many bananas from a pile. So if our pile is less than k, then monkey can eat within an hour. Total hours plus equals 1. This is one case. So what happens if our pile is divisible by k? That is pile mod k is 0. If this is the case, then monkey will take those many multiplied hours to eat all those. So total hours will be equal to pile divided by k. Otherwise, total hours will be equal to, so monkey will take this many hours to eat all those bananas, and for the remaining bananas it will take 1 more hour. So here this is how we did calculation even while explaining that solution. So by going through all the piles, monkey will spend these many hours, and then we have to check at any point our total hours exceeds the given h. So if total hours is greater than h, then time limit exceeded, then we have to return false. If monkey is able to eat all the bananas, then we can return true. So this is the function that we are going to make use it here. So finally, after doing all these things, we'll return the min k. So that is the minimum rate at which monkey can eat, so that it can finish eating all the bananas from all the piles within h hours. So this is how solution is supposed to work. Let us submit the solution and check whether it is passing the initial test cases or not. Yes, as you can see here, the solution is passing the initial test cases. Before submitting the solution, let us discuss about time and space complexity. time complexity, so what we are doing is we are going through the piles once to find out what is the maximum pile which is present. So that is O of n, and then what we are doing is mm, we are calculating this from that range, we are calculating the mid. So this becomes log of max of p, that is maximum value which is present in the pile. And for each value, then we will go through this thing again. So that will be multiplied by n. So I hope this makes sense. If we simplify this further, this becomes O of n times log of maximum value which is present in the piles. So this is the time complexity. For space complexity, so we are using some variables to store these total hours, max file, left, right for doing this binary search. These variables memory usage will not increase with the input size. So we are using constant space. So we are using constant space complexity, and for time complexity, that is O of n times log of maximum value which is present in the piles. Let us submit this solution and check whether this passes all the test cases. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithms, you can check out other videos from my channel, and please subscribe to my channel. Thanks for watching this video.